In Lesson 20, we're looking at the simplification of radicals in a line parallel to a given line. Our first example is simplifying radicals, and we have two terms here being subtracted, and the first thing we need to do is simplify under the radical, and what we'll want to do is factor those numbers under the radical. So the first one, we just leave the 3 alone, and we're going to factor 50. So we would have 2 times 25, and we can factor that again as 2 times 5 times 5. Okay, now there are 2 5s, and since the radical is just a square root, it has that understood index of 2 there. We can take out one of those 5s and multiply it to the 3 that's already on the outside. And then the 2 is left under the radical. So we would have 15 square roots of 2. Okay? Then we want to go ahead and simplify the other term. So we have minus 5 square roots, and I have 200, so that would be 2 times 100. And then I'll simplify again, or factor again. And this is 2 times 10 times 10. Now we can go ahead and continue factoring, looking for groups of 2, but I already see 2 10s right here, so I'll go ahead and take a 10 out, and it will multiply by the 5 that's on the outside. And the 2 is staying under the radical again. So it's minus 50 square roots of 2. And now that they both have the square root of 2, these are like terms, and we can actually go ahead and subtract. So 15 minus 50 is a negative 35, and the square root of 2 just stays the same. So negative 35 square roots of 2 is our answer. Alright, and again on the second example, we are simplifying. Now we could just go ahead and multiply these just like they are, but since they have those radicals, and I see this is a 12, I know that simplifies, so I'm going to go ahead and simplify it. If you don't recognize that it simplifies, you don't have to start with that. But since I see where I can simplify, I'm going to go ahead and simplify. So the 3 square roots of 2 is just going to stay the same. We have 4 times the square root. Now I can break the 12 up as 4 times 3 and times 2 square roots of 3. And this again can factor, so 4 square roots of 2 times 2 times 3. Then times 2 square roots of 3 stays the same. And that 3 square root of 2 over here stays the same. Well, here I have 2 2's, or a pair of 2's, so they could come out and multiply with the 4. So that would be 8 square roots of 3 times 2 square roots of 3 times 3 square roots of 2. Now I'm going to multiply these two together first, simply because I see that they both have the square root of 3 underneath. And when I multiply the square root of 3 by another square root of 3, it's going to give me just a regular 3. So I'll have 8 times 2, which is 16. I'm just going to continue over here, 16. And then times 3. So that's going to give me 48. Okay, so I'll have, continuing from that spot, let me move this over a little bit to give us some more room. There we go. So I'll have 3 square roots of 2 times 48. Okay, so then I'll have 3 times 48, which is 144, and then the square root of 2 just stays the same. And that is our final answer when we multiply all those together. Oops. Alright, again, let me move that so we have a little bit more room to work with. There we are. Alright. So our next example, we're going to be using the distributive property to multiply this 4 square roots of 3 across to two other terms that contain radicals. Now remember, you multiply the outside number with the outside number and the inside number of the radical with the other number under the radical. So here I'm going to have 4 times 2, which is 8. Then the square root of 3 times the square root of 3, which is just a regular 3. I'll have 4 times, there's an understood 1 here, so a minus 4. So 4 times negative 1 is a negative 4. And the square root of 3 times the square root of 6 is the square root of 18. Okay, and go ahead and multiply these together to give me 24 minus, now this needs to be simplified, so I'd have 4 square roots of 3 times 6 minus 4 square roots of 3 times 3 times 2. I have a pair I can take out, so I'll have minus, now it's 4 times 3, so that'll be minus 12 square roots of 2. So 24 minus 12 square roots of 2 is our final answer. Our last example in lesson 20 is finding the equation of the line that is parallel to another line. So in this example, we're given the equation 2y minus x equals 2, and we're told that the line that is parallel to it passes through the point 3, negative 1. So the first thing that I'm going to do is get the y by itself, so it'll be in slope-intercept form. That's y equals mx plus b. So that the y is by itself and I'll know what the slope is, and then I can put in the point 3, negative 1 to find out what the y-intercept or the b value is. So first I'm going to add x, so I'll have 2y equals x plus 2. So when I added the x, it just moved to the other side and changed signs. But if you need to see that step, let me write that in. Then we'll just divide everything by the 2 because that is the number that's being multiplied by the y. So I'll have y equals 1/2 x plus 1. Now this isn't the actual equation we're looking for. We need a line that's parallel to this one. So I'm going to fill in the 3 for the x, because that's my x, and the second one is my y. So the 3 will go in for the x, so 1/2 times 3 equals a negative 1 goes in for the y, and then we're just going to put plus b because this y-intercept is what we are searching for. So I'm going to multiply this 1/2 times 3 is 3 over 2 plus b equals a negative 1, and then I can subtract with 3 over 2 on both sides. So to get like bases or like denominators, I'll have 2, and this will be 2. So that'd be a negative 5 over 2 equals b, or a negative 2.5. So that is what we're going to fill in place of the 1 here for our y-intercept. So we have y equals 1/2 x minus 5 over 2, or you could write it as negative 2.5. Either way, this is the equation of the line that was parallel to the given line.